Hi, hello, namaste. A very good day everybody to all those who are watching video over there. Welcome back to with Academics. So guys, today I am here back with a new chapter for 10th grade students, that is carbon and its compounds, which is all about the element carbon. So now don't think that we do have around 118 elements. Is it that? Are we going to study about all these elements as a chapter in our higher classes? You don't need to worry about that. We do have a solution to simplify that learning that you will be going to study in the very next chapter. Okay, so let's focus in this chapter. As the carbon is a very important element, we are going to study it as a particular chapter. By the end of the chapter, you will be going to get to know that if carbon is not there, the life would have been very difficult to lead. Okay, so let's start to know what is the importance of the carbon. So let's get into the chapter. So firstly, let's see the outline of the chapter. So we do have an introduction part and we will see about the covalent bond, allotropes of carbon, and we will see the versatile nature of carbon, and we will discuss about the organic compounds, saturated and unsaturated compounds, and also functional groups, homologous series, and nomenclature of the carbon compounds. And we will see chemical properties of the carbon compounds, and we will discuss some useful carbon compounds such as ethanol and ethanoic acids. And at last, we will discuss about soaps and detergents. Okay. So, in this session, we will be discussing about this introduction part of the carbon and its compound chapter. Okay. So, let's see. So, you can see different objects on the screen, right? So, we do have a sugar, glucose, vinegar, pencil, coal, charcoal, cloths and all. So, we do know that it have a different uses like sugar. It gives sweetness for the dishes, glucose which gives energy for the people, right? As the athletics do use this glucose and all, right? Even when you feel sick, we do use glucose which gives energy. And ethanoic, that is vinegar, which is acid, right? Which gives which have a sour flavor, and it adds sour flavor to the dishes too. And we know pencil we do use for writing or for sketches, right? And the coal and charcoal, fossil fuels, we do know the importance of the fossil fuels in our day-to-day life. And coming to this cloths, of course, it's a very important thing that to protect us from the various climatic conditions and also from the insects, right? So, you can see that this bunch of objects, they are different from each other. They do have a different rule, they do look different, and they do have different colors and all, right? So, but what inspired from the differences, okay, they do have one common thing that all these objects do have. Can you guess it? So, if you can concentrate on the composition of all these objects, okay, like sugar. Sugar is nothing but C12H22O11, okay. Coming to this glucose is nothing but it is made up of like C6H12O6. Okay, whereas vinegar is nothing but ethanoic acid, that is CH3COOH, that is ethanoic acid. This is, we know that it's a graphite. Okay, so pencil, this is a lead pencil, right? Just because it contains lead, it doesn't mean that it is made up of element lead. Okay, so being science students, you should be clear that it is a graphite. This lead is nothing but a graphite. Clear? Coming to this fossil fuels, which is a pure form of carbon, all these three, this fossil fuel and graphite, that is coal, charcoal and graphite, it is pure form of carbon. Coming to this cloths, we do know that we do use synthetic fibers which are nothing but a polymers, right? Like we do have a polyester, right? Polyester, it is nothing but a polymer of is ester, that is nothing but a carbon compound. So, what is the common thing in all this? That is carbon, right? Everywhere we do have a carbon in all these things. That is, carbon is a common thing in all these different objects. Okay. So, not only in these things, we do use, the things which we use do contain carbon in it, like the shoe polish that you use, okay, the printer that prints the books, that do contain the printing, that print is there, no, the black print, that do contains carbon in it. Not only that, the books that you use for studying, that contains cellulose, which is again a carbon compound. Okay, not only that, if you can see, if your body do contains around 18% of carbon in the form of carbohydrates, vitamins, in the form of carbohydrates and vitamins. Okay, if you can see, we do know that plants are a very important basic thing for us, right? That it prevents soil erosion, it gives shelter for many animals, it prevents global warming, we can use it as a medicinal purpose and all, right? If you can see here, we do know that is a photosynthesis, that is preparation of food for the plants, right? So, even there, the plant do need carbon, and the byproduct, that is glucose, that also contain carbon in it. Okay, so if you can see the equation, can you balance it as you already learned in the first chapter, right? So let's try to balance this one. Okay, so we do have a hydrogen. How many hydrogen we do have? We do have here 12, so let it make 12 by putting 6 over here. So if you can see carbon, 6 carbon is there. So what about the oxygen? 12, 18. So here we do have 6 and 8. So if you put 6, yes, all right. So now we have a balanced equation, right? So you can see the plant, which is a very basic thing in our day-to-day life, which is a very useful thing, do need carbon. It absorbs carbon dioxide, right? And the byproduct that it gives is also what? A carbon product, and we do use from that itself, right? So now tell me, the carbon is a very important thing, isn't it? Do you agree that? Yes, carbon is a very, very important thing, okay? As for today's data, as for till now's data, we do have around 1 million carbon compounds in our environment. We do have around 1 million carbon compounds, okay? So let's see how much carbon is available, that is abundance of carbon in our environment, okay? If you can see in earth crust, we do have around 0.02% of carbon, that too in the form of minerals, that is hydrogen carbonate and carbonate, even in the form of fossil fuels like petroleum, coal and all. In that form, on earth crust, we have carbon around 0.02%. Coming to the atmosphere, we do have around 0.03% in the form of carbon dioxide. Clear? So, totally we do have a 0.05% of carbon in the environment. Clear? So, only we have this much amount, that is only 0.05% of carbon. Within that, from that, we do have around 1 million, more than 1 million carbon compounds. How does it possible? Isn't it very interesting? So, let's say something, let's discuss the properties or a few things about a carbon, okay? So, the element carbon, whose symbol is C, we represent the carbon element in terms of a capital C, okay? Make sure whenever you write a carbon symbol, it should be a capital C. Atomic number, that is 6, that is number of protons or a number of electrons in carbon atom is 6. Clear? Atomic mass is 12. We got to know that proton is 6. So, how much will be neutron now? So, we do know that atomic mass is nothing but sum of protons and neutrons. So, proton, the atomic number is 6. So, proton is also C. Number of proton is also 6. So, coming to the neutron, of course, even the neutron will also 6, the number of neutrons. So, what is that? The carbon contains 6 electrons, 6 proton and 6 neutron, right? So, coming to this electronic configuration, we got to know that 6 electrons are there. Electronic configuration, what do you mean by electronic configuration? The arrangement of atoms, the arrangement of electrons in an atom. So, we do the first shell will contain 2 electrons, the remaining 4 electrons will be filled in the next shell, that is 2, 4. So, the first shell will have 2 electrons and the next shell will have 4 electrons. This is how the electrons in a carbon element is arranged, 2, 4. Coming to this valence electrons, what do you mean by valence electrons? The number of electrons present in the valence shell. So, the outermost shell. So, which is the outermost shell? L. So, how many electrons are there? 4. So, valence electron is 4. Coming to the valency. What do you mean by valency? We do know that element to attain stability do form compounds, either by forming bonds, right? Either by losing or gaining, okay? So, as it have 4 valence electrons, it should either lose or gain somehow okay, and form bonds. So how many bonds it can form? It can form bonds, 4 bonds to attain stability. That is valency. Valency of the carbon is 4. Okay, so let's see, as we got to know that the elements do combine to form compounds to attain stability. So let us see about the formation of NaCl, that is sodium chloride, which is a common salt, right? We have already discussed in the previous chapter, so let's revise it. Okay, so we got to know that what the sodium, whose atomic number is what? 11, and the electronic configuration is 2, 8, 1, right? So to attain stability, what it has to do? Either it have to attain, or it have to gain 7 electrons, or it has to what? Lose 1 electron, right? So that it will have 8 electrons in its valence shell. So if it gains 7 electrons, it will have 8 electrons in its third shell, that is valence shell. Or if it lose 1 electron, it will have 8 electrons in its valence shell, that is second one. So which will be convenient for sodium? Obviously it will lose its electron, because gaining 7 electrons is difficult than losing 1 electron, right? Losing 1 electron is very easy. So what it will do? It will lose 1 electron and it will form what? Na plus, right? Sodium 1 plus, clear? So coming to the chlorine, we do know that chlorine, whose atomic number is 17, the electronic configuration will be 2, 8, 7. So what are the chances? Either it should gain 1 electron, so it will become 8, that the valence shell will contain 8 electrons and it attains stability, or else it should what? Lose 7 electrons, so that the second shell, which will be a valence shell, if it loses 7 electrons, and it will have 8 electrons. So for it is very easy to gain 1 electron to attain stability. So what it will do? We got to know that sodium have 1 extra electron. The sodium will donate electron, will lose 1 electron to the chlorine. So what happens? It will get 8 electrons in its valence shell and it will form chlorine minus. Okay, what will it form? It will form chlorine 1 minus. Clear? So this, as sodium is giving 1 electron, that is donating 1 electron, and chlorine is gaining 1 electron from the sodium. So what happens? By this, the bond is forming. The compound sodium chloride is formed by what? Gaining and losing of electron among them. So once after what? The sodium donating electron, it forms cation, that is positively charged species, whereas chlorine, which forms anion by gaining 1 electron, that is negatively charged species. So the bond formed by them will be very stronger, as we know that oppositely charged species, as it is an oppositely charged species, and we know that opposite charges do attract each other very strongly. So now the bond formed is between the two opposite ions, that is cation and anion. And this the ions are produced, ions are formed by gaining and sharing of electron, gaining and losing of electrons, right? So this bond, we do call it as ionic bond, that you have already learned clearly, right? The bond which is formed by losing and gaining of electrons. And we have studied the properties of ionic bond also, as it is formed by the oppositely charged, the bond is formed by opposite charged species ions. It is a very, very strong bond. Clear? So you got to know that this is how the elements do form compounds. How? By losing and gaining of electrons. Now let's see how do carbon attain its stability. Okay, either will it lose or gain or electrons. So we know that carbon have whose atomic number is 6, the electronic configuration is 2, 4, right? So we do have a 2 in its first shell and 4 electrons in the last shell, right? And we do know that it do have a 6 protons and 6 neutrons in its nucleus, right? So to attain its stability, we do know that element should have either in its valence shell, if its valence shell is first shell, means it should have 2 electrons in it, that is duplet, or else if the valence shell is more than 1, if element contains more than 1, means the valence shell should have 8 electrons. So it have either it should lose its 4 electrons, okay, it should lose its 4 electrons, so that its valence shell, that it will have only 1 shell, so that can have only 2 electrons. So the one thing is either it can lose 4 electrons, so that it will have a duplet in its valence shell, or else it should have what? It should gain 4 electrons so that its valence shell will have a 8 electrons which will attain the noble gas configuration, right? So what will be the condition? Either it should lose 4 electrons or gain 4 electrons. So let's see how do it attain, what happens when it gains 4 electrons, okay? So we got to know that carbon have a 6 electrons, right? So what happens if it gains 4 electrons? Carbon being a very small element, okay, because it have only atomic number 6 and we know that carbon is a very small element, okay. So what happens if 4 elements get added in the orbit? Okay, so that it will have 8 electrons. So let's discuss this first condition. So what happens when it gains 4 electrons? We know that electrons will be revolving around the nucleus, right? In the orbit, the electrons will be revolving. So upon adding this 4 electrons in its valence shell, no? So the electrons here will feel repulsion. So they do experience repulsion. The electron repulsion will happen in the orbit. So it leads to it leads to disturbance in the carbon element, okay. So as the carbon element is very small, on adding electrons in the orbit, valence shell, the electrons present already will feel repulsion. They start repelling the electrons that are getting added. So what is the first thing? It leads to electron repulsion. Clear? Whereas the other thing is, how many protons we do have? We do have 6 protons in the nucleus, right? And the these protons and neutrons are the one which holds the electrons, right? Without repelling with each other. So what happens when the 4 electrons are added? How many electrons will it be? The carbon will contain 10 electrons in its element, right? So for the nucleus having 6 protons, to hold this 10 electrons will be difficult. It will be burden for the nucleus to hold all these 10 electrons in its carbon element. Clear? So what happens when if carbon gain 4 electrons to attain stability? One thing is it will lead to electron repulsion, and the next thing is if it gains 4 electrons, it would be difficult for nucleus with 6 protons to hold on the 10 electrons. So upon adding 4 electrons to the valence shell, the carbon will end up with the 10 electrons, whereas the proton number will remain same, that is 6 protons. So as the carbon size is small, it do experience electron repulsion, and as the carbon do contain only 6 protons, it will be difficult for the nucleus with the 6 protons to hold the 10 electrons in it. Clear? So now let's see. So it feels that carbon felt that it's a bad idea to attain stability by gaining 4 electrons. So now let's see the next possibility, that is losing 4 electrons. So what happens when it loses 4 electrons? We do know that carbon do have 6 protons, and this leads to the effective nuclear force, that is the force that is by the nucleus which will hold the electron towards it. These protons and neutrons are there now, which is present in the nucleus. The force that is by the nucleus which will tends to attract the electron towards it. Okay. So this effective nuclear force. Clear? It is a ability or a tendency of a nucleus to attract the electrons towards it. Clear? So what happens if it starts escaping? Okay, let the first electron let it get away. The carbon will make the electron to escape. Okay, then it will remain with only 3 electrons. So we do have 6 protons. That the nucleus will get some more energy because it have only 5 electrons to guide or to hold, right? So it holds the electrons even with a more stronger force. Clear? It is just like in an examination hall, okay? As the people start moving, the students started moving, only few students will be remain. The invigilator, the work for invigilator will be very easy, right? Then the chances for the students which are remaining here like this will be feeling very difficult to do anything. Okay, it will be very difficult to copy or whatever, it will be difficult, right? In the similar way, as the number of electrons start reducing, the nuclear charge will be more, and it will be like it have the force to hold will be increasing as the number of electrons reduced. So the carbon will feel very difficult to lose its electron. So that's the thing, that it is, even the losing of electron is a very bad idea for the carbon to attain stability. What happens when it loses 4 electrons? Carbon atom is a very small, due to which its outermost electrons are strongly held. Okay, as the duty of the nucleus is to hold the electrons, and the carbon is a very small size and the nucleus can hold it very tightly. Clear? And so outermost electrons are strongly held by the nucleus. So it is not possible to remove 4 electrons from a carbon atom because of its effective nuclear charge on the electrons, carbon atom. So now we know that we had only option that carbon means the elements do attain stability by gaining or losing of electrons. Then how do carbon will attain stability? So let's discuss that thing in the next session. So what you have to do until the next session, you have to wait. Okay, that's all for today's session, guys. I hope I made the concepts very clear. To watch few more interesting videos and to have a better learning experience with us, what you have to do, subscribe Vidvut app. And guess what? We are in the following social media. Go there and follow us to get all the updates of Vidvut Academics. At last, to be the best, always choose Vidvut. Until the next session, keep sharing, keep subscribing and keep loving us. Thank you.